Okay, so now you've learnt the rules for differentiation. Now we're going to look at implicit differentiation. Now, you've met so far pretty much all this time since you've been doing mathematics, probably since maybe year 7. You will have graphed things like 3x minus 5 is equal to y, or 3x minus 7 equals y, whatever it might be. And you might have sketched a quadratic as well in ALMS, like x squared plus 5 or something like that, translation 5 units up from x squared. Or you might have differentiated at this point now y equals sine x and maybe found where its turning points are, for example. What I'm meaning by all these equations of curves is we can write it as y equals a function of x. This is an explicit equation, it's y as a function of x. Now, with this one, for example, I could just rewrite that as y plus 5 equals 3x. That is no longer y equals some function of x, it is now an implicit equation that I could then differentiate, which is what we're going to look at in this section. Now, this one, you will have met this later down, but you will have met things like x squared plus y squared equals 1, the unit circle, right? The centre 0, 0, radius 1. Then you could prove sine squared plus cos squared is 1 from that, or tan x is sine x over cos x, for example. But we can have some silly ones. We can be like totally out of our depth here. We could have sine x plus y squared, for example, minus 3xy to the 7, which then could be equal to, I don't know, 5 minus e to the y, or 5 minus e to the 2y, for example. It doesn't matter how we write them in its form, but if it's not explicitly y equals a function of x, then it's an implicit equation. So you might see, when you did equations of lines in year 1, in year 12, you would have said ax plus by plus c equals 0. Now that is an implicit equation because it's not y equals a function of x. Whereas if you were told to write it in y equals mx plus c, or y minus y1 is mx minus x1, for example, those are, yes, they are implicit, but when you can rearrange them, they're no longer. They're more explicit equations. And I can just bring that over to here, right? So what we're looking at now is how we can differentiate when it's not y equals a function of x. What happens there? And the easiest way to describe it is saying, what happens when you differentiate just y? Well, d on dx of y is dy by dx, right? So what we're going to do now is basically see how we can differentiate when it's not y equals a function of x. That's what we'll explore in the next video.